Hello students, welcome back to the second part of the chapter on mensuration. So these are the questions I advise you to try. I hope you have already done them. So let us compare our solution. So the first question is very straightforward. We are given a pyramid, the base, okay, right angle to the peak, right, to the apex, we already know. And then the base of this pyramid happen to be a nice right angle triangle, which we should be quite comfortable dealing with, right? So the first thing they ask us to do is to find the volume, and we can do that, okay? So the volume of pyramid is 1/3 base area times height. So what is the base area now? The base area is half, and then 4, 7, right? So there's a base multiplied by the height. The height happens to be 5. So we work this one out with our calculators, and we shall get 23 and 1/3. Now don't forget your units. In this case, it is cubic meters. Right, a very straightforward question to test our understanding of the volume of pyramid. So just apply the formula, which most of you should memorize. Okay, here's the second question. So this time round is a composite question, slightly different. We have actually two cones, right, connected at the base. So they want us to find the total surface area. So in this case, we need to actually get some information first, right? For example, we know the slanted height is 15, but one information that's lacking is actually the radius. So we need to figure out what the radius is, but hey, it's not that challenging. I mean, we can see that the diameter is 14, so the area will be half of that. So let's write it down, right? First of all, let's call this part 1, right? So the radius is equals to 7 centimeter. Now with the radius in hand, we can go ahead and find the total surface area, right? So the total surface area is equals to 2 times the slanted area, right? So the 2 times the slanted area, and the slanted area is actually pi radius followed by the slanted height, which is 15. Okay, so you work this one out. So take our calculators again. 7 times 15 times pi multiplied by 2, right? That will give us 659.73, and the units is centimeter square. And of course, for this kind of non-exact values, it is always a good habit, remember, to write it to 3 significant figure. So this is 3 significant figure. Okay, so that's part 1. Part 2, to find the volume. Well, this question is requires another knowledge, and that is the idea of the Pythagoras theorem. So let me just draw the triangle for you. So what does Pythagoras theorem says? Pythagoras theorem says that if I have a right angle triangle like this, right, then the height here and the radius, their square, will add up to 15 square. Okay, so I'm going to call this h, okay, and then this is the radius. Okay, so based on Pythagoras theorem, okay, my h square plus r square is equals to 15 square. So h square is equals to 15 square, right? 15 square minus, now my r is 7, right? 7 square, which brings us to 176, right? So my height is actually this square root of 176 centimeter. So with this information, I can find the volume. Okay, okay, let's keep my purple pen. So part 2, the volume, okay, is equals to, right? Now there are two cone here, so 2 times of the cone, and the cone is 1/3 pi r square h, and the h is actually this square root of 176, right? So once again, just use our calculator. This is times 0.9 times pi divided by 3 times 2, and that will give us 1361.48. The units is in centimeter, right? And of course, once again, we can actually write it as 3 significant figure because these are non-exact, right? So we do that and says 3 significant figure. Okay, right. So move on. So anyway, just to clarify, this is Pythagoras, right? So read up on it if you are not sure about it. Okay, so moving on, next question. This time round we are dealing with a sphere. They gave us the volume and we are told to find the surface area. Okay, so we can do that, right? So what happened is we know that the volume of a sphere is actually 4 over 3 pi r cubed, which is equals to, in this case, 850. So from here we can actually find our r, right? So we have, in this case, r cubed is equals to 850 divided by 4 over 3 pi. Let me write it properly. 4 over 3 pi. So press our calculator. 4 divided by 3 times pi. This is the value. 850 is supposed to be divided by this, which gives us 202.923, right? And then if we cube root this, let's see where's my cube root on my calculator. So the radius is about 5.876 right? At least 5 significant figures to be safe. You can have more significant figures, okay? It's fine. Meters, right? So now we got our radius. We can find the surface area. Therefore, surface area of a sphere is 4 pi r squared. So it's 4 pi times 5.8764 square, right? So you do that on the calculator, times pi, times 4, and that brings us to 433.94 square meters. And of course, again, non-exact, so 3 significant figures, 434 meters square, 3 significant figures. Okay, right? And is this the final question I have to try? Yes, it is. So the final question that I ask you to try is this one over here. Again, there is a pair of cone and a cylinder in the middle, and we are told to find the total surface area. Okay, so let's see, we have all the information we need. So total surface area for the cone, we need the slanted height, right? So how do we get the slanted height? Now the slanted height is 6 meters. Do we know the radius? Yes, we know the radius. The radius is going to be 4. So I'm going to just label it now here. 4 meters so that there's some clarity. So I got my radius, I got my slanted height. I can get my necessary information. So let's go. Part 1. Maybe I write it on, just write it here. Part 1, okay. You can go ahead and add up the part together if you're confident. So total surface area is going to be 2 times the cone, right? So the cone is pi RL, right? So pi, the radius is 4 and L is 6, okay? So that is for the 2 cones. Then after that we have the cylinder, right? So this will be adding up. Let me move my page a little bit. Okay, so what we have is we need the diameter. Okay, so the diameter is going to be pi times 8, and then we multiply by 8 again, right, for the whole length. So that is what we have. So you put them together, it will be, let's use my calculator, 48 pi plus 64 pi is 112 pi, and then after that multiply using the calculator pi, which gives us 351.86 units meter square. Okay, so of course again this is a non-exact, so 3 significant figure, which will give us 352 meters square 3 SF. Okay, and of course last part, finding the volume, we are also quite capable of doing that, right? So let me just write it here. Volume in this case will be equals to, well, volume of the cone, so again 2 times, and the cone is 1/3 pi r. R is 4 pi r square h. Now we need to find the h, right? So once again we need to employ Pythagoras theorem. So I'm just going to work it out here. Okay, we have this situation, right, where this is 4 units, 6 units, and this is what we want to find, right? So that length, I'm just going to call it h for height, right? So h square is going to be equal to 6 square minus 4 square according to Pythagoras theorem, right? So h square is equals to 36 minus 16, which is 20. Therefore, my height is actually square root of 20, right? Oops. Okay, so I'm going to plug it in to 1/3 pi r square h. So square root of 20 over here, right? Wrong color, blue. So that is the area of the two, and then we need to add the area of the cone. So the cone will be just pi r square h. So pi r square, and the height for the cone, sorry, the cylinder is 8. Okay, so we work this one out. Let's do it. So we have a 16 times square root of 20 divided by 3 plus pi, sorry, not plus pi, times pi times 2. I get 149.86 plus 16 times 8 times pi, 402.12. Okay, add that out together. Give us 551.98, right? And of course, we want it, this is the units is in meters cube, but we want it in 3 significant figures. So 552 meters, okay, cube, 3 significant figures. There we go. So I hope that helps you to strengthen your understanding on mensuration and that you have been successful. If you still struggle with it, of course, please go ahead and make an appointment with me and ask me your math question directly face to face so that I can help you learn it better. All right, have a nice day.